Okay? So, exponent properties. The product rule for exponent properties. I'll focus that. Please copy this definition. When multiplying numbers with the same base, you will keep the base and add the exponents. Now, what exactly does that mean? I'm glad you asked. What that means is if I have a to the power of m times a to the power of n, the a is our base. Okay, the variable given to you is your base. The exponents will add together. M plus n. And that's the rule. So when you are multiplying variables together and they have the same letter, and you're multiplying them together, you are just going to add the exponents together. So if you're multiplying variables of the same letter, you will add the exponents. Now if you have any numbers, aka coefficients, which are just numbers in front of letters, you will just multiply them like a normal number. We'll get to that example. First example here. X to the power of 3. Now, x to the power of 3 can also be written like this. X times x times x. X to the power of 4 can be written as x times x times x times x. Now, how many x's are being multiplied together? 7. I will not put 7x, I will put x to the power of 7 because the exponent tells me how many times I am multiplying x. That's what the exponent tells me. How many times am I multiplying that specific number? Now the rule says a to the power of m times a to the power of n equals a m times m plus n. Did I do that here? No. What I did here is I wrote out the expanded form. I wrote everything out and expanded just so you can get a visual of what's actually happening. Now, what is actually happening is I'm taking x to the power of 3 times x to the power of 4. The base is the variable that's being multiplied together, x. Then you take the exponents and you just add them together. 3 plus 4, which simplifies to x to the power of 7. Hey, that's the same thing. 7. Okay? Now, example number 2, same thing, but my base is now what variable? A. So I have a to the power of 2 plus 4 because multiplying variables of the same base, you just keep one base, you just keep it, and then you just add the exponents together. What is 2 plus 4? A to the power of 6. Now, in expanded form, to prove my point, I have a times a, or 2 a's being multiplied to each other, times 4 a's being multiplied to each other. And that is 1, 2, 3, 4, 5, 6 total a's that are being multiplied to each other. It's a kid crying in the other room. Okay. Now that's if you have numbers of the same base, or variables of the same base. sometimes you're going to have numbers in front of those variables. Those numbers in front of the variables are called what? Starts with a C and it rhymes with officient. Coefficient. Okay? Now, you're going to treat these coefficients as just plain old numbers like there is no variable. So when I have 2 parentheses 3, that means I'm multiplying these two numbers together, correct? So what is 2 times 3? 6. Okay? Now, the A's, will combine, and when I'm multiplying variables of the same letter, what do you do to the exponents? Add them. So what is 3 plus 2? And that's my final answer. I know, right? So I'm going to skip 4 and 5 real quick because I want to go to number 6. Because blah, 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 blah. I just went into mumble jumble mode. Okay, number 6. Does it only have one variable in there? No. It has 2 different variables. So it's different. However, the rule still stands. Coefficients. You will combine those first. What's negative 4 times 11? Negative 44. You do have calculators, so if you don't know it off the top of your head, use your calculator. Okay. Do I have multiple x's being multiplied to each other? Yeah. Yes. I have x's in both parentheses that multiply. So if I am multiplying x's together, what do I do to their exponents? Add them. So I have x 7 plus 5. Okay. We'll simplify that here in a second. The y values. Do I have a y value in each parentheses that I'm multiplying together? Yes. Now, this says y to the power of 6. This one has nothing. What must you assume? 1. It's 1. For the y value to be there, there needs to be at least 1 in existence. Okay? So we are going to assume that it is the number 1. So I'm doing 6 plus 1. Then I simplify the exponents to where my answer is now negative 44 x to the power of 12 and y to the power of 7. Now, I also want to let you know that when you have multiple variables that you are combining, they must be written in alphabetical order because mathematicians have OCD. Got it? Alphabetical order. Yes, sir. Yes, sir. So, now that you've had multiple practices or examples shown to you, I want you to try 4 and 7 on your own. 4 and 7 on your own. Then we will spin the wheel of not ideal. For examples. I'll zoom out. There you go. All right, who is? Isa's here, Lucas is here, Brett's here, Jackson's here, Jordan's here, Diggle's here, Xavier's the one right here. Wheel of not ideal. That negative is only attached to the coefficient. Brett, you are going to do number 4. Dun, dun, dun. It's not lunchtime. No. All right, Brett wrote down negative 12a to the power of 10. Give me a thumbs up if you agree. I agree. That is correct. Awesome, Brett. Thank you very much. Now for number 7. Jose. Whoa there. Whoa there. Chill out, man. X to the 7, 6 to the 9.
Why?
Did I say 6 to the 9?
Yeah.
Ha! Well, that's because your Y looked like a 6 to me. I'm not gonna lie. I'm not wearing my glasses. Sorry. Y to the 9. Thumbs up if you agree. I 100% agree. So again, it is, for my video people, 40x to the 7, y to the 9. Okay? Corbin, do you mind going up there and erasing those two answers that those people did, please and thank you? So that's the product rule. And remember, product is the answer to a multiplication problem. Corbin. Thank you. Quotient is the answer to a division problem. So the quotient rule is when dividing... Shh. Don't get ahead of me. When dividing a base Sorry, hold on. When dividing a blah, blah, blah. When I did it in pin 2, I scratched out. Gosh, leave me alone. When dividing two non-zero powers, basically they exist. Okay, like I told you, these rules sound crazy, all right? But I'll simplify it. With the same base, there's the base. Two non-zero powers, that just means that they have a value. They don't equal 0. They're at least 1. Okay? Two non-zero powers, you're going to keep the base, drop the base. You're going to keep the base and subtract the exponents. For example, I'm going to scratch out 10 here so I can put my example here. It is a to the power of m divided by a to the power of n. They have the exact same base, so you keep the base and you subtract the exponents. Yes. So when multiplying, you add exponents. When you divide, you subtract the exponents. So here we go. Number 9 has a coefficient on them. Okay, I have coefficients here. So those coefficients, I'm going to treat those coefficients as their own entity. 8 divided by 2. 4. Now, I'm going to simplify it like a normal fraction. 4 divided by 1. Like I acted like I'm just simplifying a fraction. Now, I have x to the power of 4 in the numerator, x to the power of 2 in the denominator. The way you know where to put your variables is which one, the numerator or denominator, has more of that variable. So I have 4 x's up top and I have 2 x's on bottom. Do I have more in the numerator or denominator?
Numerator.
So because I have more in the numerator, I'm going to put my x in the numerator, and then the remainder, the subtraction, will go with that x. What is 4 minus 2? 2. So I have 4 over 1 times x to the power of 2, which can be rewritten as 4x2. Yes? You don't do the top divided by the bottom, right? I did do the top divided by the bottom. 8 divided by 2 is 4. 4 minus 2 is 2. I did do that. I just wrote it in because not every fraction of the coefficients will give you a whole number. So I'm just showing you, you will just basically simplify it. So I just simplified, and then I simplified my variables. And then my final answer became this. I could look at this and say 8 divided by 2 is 4. Boom, there's 4. And then I have x 4, x2. I have more x's in the numerator, so that x will stick with the 4. Okay? But I did it simplified version because like this one here, basically this next example, this won't give me a whole number, so I have to reduce the fraction. So what's 8 over 10 reduced to? Correct. 4 over 5. Okay? Now, I have x's and I have y's. Now, when I look at the x variable, do I have more in the denominator or more in the numerator? The denominator. So when I subtract the exponents, my x will be written in the denominator because that's where the most were. I don't want any negative exponents. I don't like negative exponents. So I just put the exponent where the most of them were, and then I just find the difference. What's 5 minus 2? 3. Okay. Now I have y values also. I have 6 y's up top, 2 y's on bottom. Where do I have them the most? The top, the numerator. So that's where I'll put my y answer. What's 6 minus 2? And that's my answer. And that's it. That's all we're really doing. I'll do one more example with y'all. Okay, one more example. Let's look at number 15. 15, we'll do 15 together, okay? Now, negative 14 and negative 7 divided by negative 7, would that give me a whole number? Yes. Yes, it would, okay? Now, I do need to look at my variables here, okay? I'm going to reduce the fraction first. I'm going to reduce it first. These are both divisible by negative 7. Would you agree with me on that? Okay, that would simplify your fraction to 2 over 1, okay? The only reason why I'm doing this right now is because I have these variables that I have to take care of. My x's, do I have more in the numerator or denominator? Numerator. So that's where my answer would go after I subtract them. What's 5 minus 1? Sorry, 5 minus 4 is 1. I said the answer out loud, okay? My y values, do I have more in the numerator or the denominator? They're equal. So when I subtract them, 4 minus 4 is 0. They cancel themselves out. So I'm left with 2x to the power of 1 over 1. Anything over 1, any numerator over 1 is just that numerator. Okay. Now, do I need to put to the power of 1? No. Would I get counted wrong? No. Because they mean the same thing. But this would be my final answer. Now, for your practice, you are going to do 12 and 14. 12 and 14, and then we'll spin the wheel of not ideal. Spin the wheel of not ideal.
Chinese TV is censoring the maskless crowds in Qatar.
Interesting. Yes, Corbin. What? Always.
Negative 3x.
It's negative 6. Negative 1. Okay. And so basically, this one's bigger. Isn't the bottom one bigger, right?
Yeah.
Okay. Okay, so but the x is on the bottom. The y is at the bottom. Yeah. No, you have to. We did still put the x on there.
Number 12, Jordan. Number 12.
Well,
Not very sure about pondering mine. I'm not sure that you take the lead that the X-ray.
There's only one way to find out.
where did you get one?
Jordan has 4 over 3 x to the power of 3 in the denominator. Give me a thumbs up if you agree.
I agree.
I also agree. That is 100% correct. The fraction does not give you a whole number, so you just simplify said fraction. Then, if you look at your variables, I have more in the denominator than the numerator, so that's where I put my x, and then the difference of the two was 3. Yay! Good job. All right. 14.
Wait, isn't it the isn't like 4 so shouldn't it be the top 4?
The majority of them are in the bottom. So x is on the bottom. I have more x's here than I do up there. I don't look at the coefficients. Don't look at those. You look at the variables' exponents. Tim!
What are the coefficients?
They're the numbers in front of variables. So, for example, 12 and 9 are coefficients. 3 and negative 18 are coefficients.
Thank you.
Dun-na, dun-na, dun-na. Pow, 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 pow. Almost. Definitely not. You are so close. I mean, like, scary close. You're forgetting one very important thing. Literally, you are forgetting one thing and one thing only. So, for the people in the videos, right now, Tim has this. This is what Tim has so far. What is the one excruciatingly important thing that you left out in your answer? The negative. The denominator was a negative 18, so when you simplified it, it should still stay a negative. Now, the x's cancel out because 3 minus 3 is 0, and then I have more y's on the bottom, so I put the y at the bottom in the denominator, and then the difference between 3 minus 1 is 2. Do not forget the negative when you reduce. You're reducing by a positive 3, so negative 18 divided by a positive 3 is a negative 6. Questions, comments, concerns, or tribulations? Or can we move on to the last page of the notes? Last page for at least today. Last page for at least today. Yeah, it goes by fast. Jack, this time, do you mind going up there and erasing the board, please, and thank you so much. Power to power. Now, you're probably going to be extremely and utterly confused to begin with, but I'll simplify things very easily. Power to power. When a power is raised to another power, you will keep the base and multiply the exponents. For example, I have a to the power of m. Well, that entire value is also being raised to the power of n, which will be rewritten as a m times n. You will multiply the exponents together. Now, as you can see, what do I have in this problem? Starts with a P and it rhymes with parenthesis. Parentheses. Parentheses. Okay? Now, whenever I have a parentheses, whenever I have a parentheses, what main concept do we do to get rid of said parentheses? Distribute, which is multiplication. This is why we multiply power to power rules, because essentially, basically, all you're doing is distributing. And when you distribute to everything inside the parentheses. So I have x squared to the power of 3. I'm just rewriting it a little bit bigger. I'm going to distribute this exponent to everything in the parentheses. So really what I'm doing is showing that I have x 2 times 3. What is 2 times 3? So essentially, I'm doing the same rule that we did at the beginning of the school year. When you distribute, what operation do you do? Multiply. When you distribute, you multiply. That's it. The only difference between what we have done and what we are doing here is we are multiplying the exponent and not the whole numbers. Okay, we're multiplying the exponents. Here's the next example here. Again, I'm just going to rewrite it bigger. I need to get rid of the parentheses, aka distribute the exponent. I'm going to distribute the exponent to everything. To everything, including the coefficient. This will be rewritten as, now please, please, please do this. The reason why I'm putting a parentheses around the -3 coefficient is because it is a negative number. Because if I go into my calculator, and I'll show you what happens. If I just did -3 squared, and I hit enter, what do you think I'd get?
Error.
Not error. I would get -9. However, I don't want -9. What I'm looking for is -3 times -3. So when I put it in parentheses and then raise it to the 2, I get the +9, which is what I'm actually looking for. Because what I'm trying to say is I am multiplying -3 2 times. When you don't put a parentheses around your negative number, what the calculator assumes is happening is -3 times +3. But really we want -3 times -3, so we put the negative number in parentheses. Now, you will not have to put a positive number in parentheses. That's totally fine. It's only when I have a negative coefficient. It's the only time. Okay? So, More practice. Looking at number 20. We're going to go to 19 after this one. Okay, number 20. I want to distribute this 2 to what? To everything. Every single exponent possible. So what I have is parentheses -2 squared x. Now x already had a 2, correct? So when I distribute this exponent to another one, what do we do? Multiply. So I have 2 times 2, and then I have y 3 times 2. Because I distributed an exponent, they already have an exponent there, so I multiply them together. -2 times -2, aka -2 squared, is +4. X, 2 times 2, will give me x to the power of 4. And then for the y value, I'll get 6. When you distribute to everything inside or outside the parentheses? Inside the parentheses. Now, why is Coach Kimball asking you that question? Because of question number 19. I have an exponent outside of a parentheses. So I need to do what? Starts with the letter D and it rhymes with distribute. Distribute. So I'm going to distribute that 2 to everything inside the parentheses. Am I distributing it to the 3? Because where is it? Outside. So now I have 3x to the power of 4 times 2 squared. If you take your calculator and you do 2 squared, you get what? 4. And then I have x to the power of 2. Hold up. Wait a minute. I just distributed, and now I created a product rule. I now created a product rule. 3 times 4. I multiply the whole numbers just like they are. What's 3 times 4? 12. If I multiply variables together, what happens to their exponents? You add them. If I multiply variables of the same base, you add the exponents together. What is 4 plus 2? 6. It is fairly simple. You just got to remember that if you have a number outside of parentheses, you must distribute. Now we're going to do 22 together because it is a fraction. Now nothing changes. The rule still stays the same. I will distribute to everything in the parentheses. So I'm going to distribute to the 2, to the x in the numerator, to the x in the denominator, and the y in the denominator. Distribute to everything. To the point where I have everything. 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 So I have 2 to the power of 3. X 3 times 3 over x to the power of 3, y to the power of 3. Now we simplify. 2 to the power of 3. What is that? Wrong. Wrong. What? No. 2 to the power of 3, which also means 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So actually, 2 to the power of 3 is 8. Excuse me. 3 times 3 is 9. These in the denominator are already simplified. Now, I have simplified the distribution. However, I have not finally simplified my whole answer. I have not officially done that because I have a fraction where I have an x in the numerator and the denominator. So that must be simplified. Now, I can rewrite this already. 8 over, because 8's not going anywhere. The y is not going anywhere because there's no other y to compare with. So I look at the x. Is the x going to go in the numerator or the denominator? the numerator because I have more of them in the numerator. Then I just find the difference. What's 9 minus 3? 6. With that being said, you are going to try 21.
Sorry.
And you are going to try 25. 21 and 25 are the two that you are doing. 25 is a special case, and maybe, hopefully, kind of, sort of, possibly, you'll see why. Or you can be like Ben and just be asleep the whole time. He has a pen in his hand, but he has done nothing. Right, Ben? Right, Ben? See? That's what happens when you show up to class in your PJs.
Oh, he's doing the math problem instead.
Okay.
Okay, so.
He's just ignoring me.
She just started and I'm finished.
Issa says she's already finished them all, so let's go ahead and spin the wheel.
No, wait. Unless it's gonna call on her and don't spin the wheel.
Well, the wheel chooses. I don't choose.
Wait.
Fate decides.
I think my calculator was broken.
How come?
Remember, when you take a coefficient and raise it to a power, it's not just saying 5 times 3. It's basically saying 5 times 5 times 5.
5 times 5.
That's what 5 to the power of 3 is. That is adding. 5 times 5 is what? What's 25 times 5? 25 times 5. 5 to the power of 3 is 5 times 5 times 5. What's 5 times 5? I still have another 5, so 25 times 5 is? It is over 100.
I mean, 125. You were right. You were right. 600. 125.
So what, is it written?
You did it right.
Wait, so what did you get?
It's my fault.
I didn't get that thing.
You said
What
you
is
were
our
right. I don't want to.
You know, you could just use your calculator and do 5 to the power of 3 and just see what it says.
Exactly 125.
Yes.
Yes. That's nice.
That's 5.
I mean, you have
No, I was thinking of Lucas. Oh, I know. And then I realized, you guys are trying to find a five.
What is 100? What
I
are
was so
those
confused.
How come you just say 5? He said 5 times 5 times 5.
Because 425.
125.
So you add another one.
Not 15.
5 plus 5 plus 5 is 15.
So would it be 125?
What is the...
125.
It's the exponent.
It's 125.
The coefficient, you distribute that 3 to everything, right? So you distribute it to the 5, the x, and the y, right? Well, if I distribute it to the coefficient, that's 5 to the power of 3, which is 5 times 5 times 5. That's all exponents is. Exponents just tells you how many times am I multiplying that certain thing. That's all an exponent is.
Wait! Wait!
Elva.
You did it wrong.
How do you just start on 25?
21.
I'm pretty sure you got 21 there.
Everyone better start working on 25.
But,
I love one.
okay, 25.
You were so close to the
I
end.
don't know what I'm doing. Me either.
Yeah, write down your answer. You know exactly what you were doing.
Actually, not on this. I don't know. Not on this.
Who decided to put letters in them?
I'm so
Exactly.
Desi for the golf.
Huh?
Is Desi for the golf?
What?
I don't know. I haven't seen him play in like 2 years. I was his golf coach when he was seventh grader
Well,
at junior high.
Does he not play
it's
I have no idea.
it's 4 to the power.
He probably does. I don't know everyone that's on the team right now.
Oh, what am I right?
He hasn't said it's no.
Thumbs up if you agree.
Yeah.
Yeah.
Oh.
Oh.
I don't agree. Okay. I do, however, agree with the exponents on the variables. Okay. The exponents on the variables. So for the people in the video, this is what we have being shown right now.
I see it. Oh wait, no.
Okay. This is what was written. Okay. Now, what is wrong about this is the coefficient. The variables are correct. The variables are correct. When I distribute this 3 to the coefficient, that is 5 to the power of 3, or 5 times 5 times 5, which I've been saying forever now. 5 times 5 is 25. 25 times 5 is 125. So my answer should be 125x to the power of 12, y to the power of 3. Again, your variable exponents were correct. It was just the coefficient.
I thought you added.
That's on the first.
That's power to power. That's if you're just flat out multiplying. This is distributing. So when you distribute, you multiply. We are distributing, Brett. We're distributing. So anytime you distribute, no matter what the case, if you distribute, you multiply.
So it's X.
X to the power of 12, yes. All right, spin the wheel of not ideal for 25.
Oh, let's go. I don't know how to do it.
It's probably because you've been asleep the whole time. I don't know. If you got an error in the calculator, then I have no idea what you're doing, because technically you shouldn't be doing anything in the calculator.
Oh, I don't have it.
2.
I don't have it.
You already won.
No.
I don't have it.
What are you? Oh my god.
Blame Jordan.
Okay, I have it. I got you.
The reason why we spun again is because Jordan goes like, because Tim already went.
Yeah,
He says probably right. I don't know if he's sure.
This is fair. It's literally random. It's literally random.
literally random. I was chosen once and it wasn't
These are
first
some
question.
big numbers.
Big numbers.
I don't have it right.
Why?
All right, so for the video, people. All right, so for the video, people, this is what Issa has. 343 x to the power of 15 over 64 y to the power of 9. Thumbs up if you agree. Thumbs down if you disagree.
I agree.
I agree. It is correct. So what we are doing again is you distribute to everything in the parentheses. Everything. 7 to the power of 3 is 343. Okay? 4 to the power of 3 is 64. Then you have x 5 times 3, which is 15. And then you have y 3 times 3, which is 9. No variables on either side of the fraction bar, so I don't need to simplify anything. And also, 343 over 64 is in simplest form. Can't simplify any further than that.
I still do the non-multiplying.
Ah. So with that being